Walaikum assalam, sir. Yes, I can hear you.
Okay. We are doing questions on gravitation as a series of our past paper work. Uh, this is June 13, 41-1. If you have this question, in your book, you can take it out. State what is meant by a gravitational field. It is a in the solar system, the planets may be assumed to be in circular orbits about the sun. Data for the radii of the orbits of the Earth and Jupiter about the sun are given. State Newton's law of gravitation. So we can orally recall it. What is Newton's law of gravitation? Newton suggested two main concepts. Force is directly proportional to the product of the masses, and force is inversely proportional to the square of the separation. Newton suggested that the force of attraction between two point masses is directly proportional to the product of their masses and inversely proportional to the square of the separation between the masses. Use Newton's law to determine the ratio gravitational field strength due to the sun at orbit of Jupiter, orbit of Earth, gravitational field strength due to the sun at orbit of Jupiter. So we have a ratio Earth to Jupiter. This is the formula. And here, when you are talking about Earth and Jupiter, the gravitational force will become the weight, will become mg. And here we can write, this is a type of derivation. Now look at this. If you compare them, if you equate them, then mg will be equal to gm m upon gravitational field strength means G. So now you can make the ratio. Ratio is equal to G due to the sun. So Gm upon x1 square upon Gm upon x2 square. Because sun is the same, so I'm not changing the mass. G is already a constant. The fraction reverses when it comes up. Now I have to see the orbit. I have to see the orbit. Earth orbit, and it's in kilometer. Earth orbit and Jupiter orbit. It's Earth upon Jupiter, but my ratio has reversed. So it will be Jupiter upon Earth. 7.78 into 10 power 8. I'm not changing kilometer to meter. Why? Because it's a fraction. Now, if I change both of them, it will be cancelled. So you say answer is to 26.9. Acha. The orbital period of the Earth about the Sun is capital T. Use ideas about circular motion to show that the mass m of the Sun is given by this. This is a famous thing which is called Kepler's third law, because when something is orbiting a center, the gravitational force provides centripetal force. This is called the most famous definition in most famous derivation in this course, in this chapter, actually. So look at this small step and sorry. This is the derivation, and this is Kepler's third law. The orbital period of the Earth about the Sun is this much second. The radius of the Earth is given by this. Use the expression to determine the mass of the Sun. So this is just like giving you the data. This is T. The R is given 1.5 into 10 is to power 8. First make the data. First make the data and then solve. What value you got for M? Did you get the value of the mass of the Sun? Two in 10 power 30. Explain what is meant by a geostationary orbit. What is a geostationary orbit? In which the spin time period of Earth, spin time period of the Earth becomes the orbital time period of the satellite. spin time period of the Earth becomes the orbital time period of this is called geostationary orbit. Geostationary orbit is an orbit whose time period is the spin time period of the Earth. It is known as a position where the object is logged, and it appears to be on the object, it appears to be stationary from the Earth. This is June 1342. It's a 3-mark question. Such parts should always be checked from the examiner report, because examiner report is actually very important in that sense. June 1340. We are solving June 1342-1. There were many comprehensive answers, but it was common for some aspects such as direction of motion or time period to be omitted. There were some answers where no reference was made to the Earth, also stating that the satellite has the same period of rotation is ambiguous. So he wants people to mention direction of motion west to east. That in this orbit, satellite move west to east. It has the same orbital time period as the time period of the spin of the Earth with 24 hours, and it should be in front of equator. It should be on equator for the orbit. Geostationary orbit is always geostationary orbit is always on the equator position. So we went to that examiner report because the marks were too high. Now read the next part. Now, if you read the next part, and I have shared the brief description of geostationary orbit again, and this will be helpful to recall this thing because marks were too high. A satellite of mass m is in a circular orbit about a planet. The mass m of the planet may be considered to be concentrated at its center. It means it's a point mass. This type of info means that it is It is a point mass. So that the radius of the, then again, it is the same geo that he's asking to go for. This is their favorite derivation. This is where A2 is really different, really very nice. That keep on asking one thing, that Kepler's third law. Omega can be converted into time period. Now you have to make R cube the subject. This is the derivation. Kepler's third law. The Earth has mass this. Use the expression to determine the radius of the geostationary. So he has given the mass. So this is the data. Work out the data. So if you can check the answer, let me know if you can get the answer. Okay. November 13, 41-1. Define gravitational potential at a point. Gravitational potential at a point is the work done in moving. It is the work done per unit mass from infinity to that point. So gravitational potential at a point in a gravitational field is the work done per unit mass to move the mass from infinity to that point. It's a definition memory. The moon may be considered to be an isolated sphere of radius this with its mass of this concentrated at its center. This language always means that we assume that moon is a point mass. A rock of mass 4.60 kg is situated on the surface of the moon. Show that the change in gravitational potential energy of the rock in moving it from the moon's surface to infinity is this. So you have to read the question. So moon's surface is the radius actually, and infinity means that is far away where the potential becomes zero. This is the formula. It's 1.74 10 power 3. This is a symbol for infinity. And remember, 1 upon infinity is equal to 0. So now solve this big line of data. This is a question related to show. So the answer is given, but we have to prove it. The escape speed of the rock is the minimum speed that the rock must be given when it is on the moon's surface so that it will escape to infinity. Use the answer in part 1. Determine the escape speed. So object can escape when the kinetic energy exceeds the potential energy. We had done this derivation in the class also. Right. The moon in part B is assumed to be isolated in space. The moon does in fact orbit the earth. State and explain whether the minimum speed for the rock to reach the earth from the surface of the moon is different from the escape speed in calculated in B. So in the reality, moon is not isolated. Moon is orbiting the earth. Moon is orbiting the earth, so moon, anything moving from the moon's surface will be affected by the earth gravity also. So earth will also attract this rock. Now it's not a case of infinity. Earth is a position now, and earth potential won't be zero. So when you throw the rock from the moon towards earth, earth is actually attracting moon, so earth will be attracting this rock also. Now as the earth is already attracting the rock, so you won't need that much speed because earth is there to pull it out. So it is just like the case, initially it was going to infinity, but now it is not a case of infinity. Now it is not a case of infinity. So you can say that it is not a case of infinity. So you can say that earth is now there to attract the rock. So you can write the answer that earth attracts the rock. It is not a case of infinity. Let's escape speed. So you have to copy this. There were some correct responses based on the fact that the earth would attract the rock. It was rare to find an answer based on the effect of the earth potential. Many candidates made a comparison of the moon and the earth based on these two being isolated in space. So that's a point. This is the benefit of referring to is not zero. So we keep it up to here, and we will inshallah continue this in our next class. Allah Hafiz.